57. What volume of 0.20 molar HCl will neutralize 40 milliliters of 0.1 molar NaOH? Well, both of these have one proton or hydroxide, so we don't have to account for that. And all we need to do then is use our formula for neutralization slash titration slash dilutions. MAVA equals MBVB. So molarity of the acid is 0.20, 0.20. The volume, well, that's what we're looking for. We're looking for the volume of the acid required. Next, the molarity of the base is 0.10, and its volume is 40. And so when you're using this formula, as long as you're consistent with your units, molarity and volume being in liters or milliliters, it doesn't matter. So I'm going to keep this as 40. You could turn it into 0.04 if you wanted to in liters, but it's fine. You can just leave this as 40, and then the VA you get as your answer will be in terms of milliliters. So I'm going to get 0.10 divided by 0.20 times 40. And this is just a half, right? You can kind of move this over 2 decimal places. 10 over 20, that's a half, and a half times 40 will give me 20 milliliters. So the answer, 257, will be C. And if you think about it, it makes sense. The molarity of the acid is twice the molarity of the base, so I would only need half as much of the acid in order to dilute or to neutralize that base. So it makes sense. Which are true of aluminum? So a little bit of outside knowledge on this one. Some you might be able to get just based on the fact that aluminum is a metal. You would know, since it's a metal, it's going to conduct electricity well. In terms of the others, a little bit tricky. You might know from experience that aluminum is actually quite light compared to other metals, so it's actually got relatively low density compared to something like lead. So that is false, so B looks good. It does form a protective coating in air that resists further corrosion. Basically, as the oxygen reacts with the aluminum and you form aluminum oxides, you get like a coating which prevents further rusting, further reactions with the air. So that is true. Next is, if I can find my pen here, next is D. It's an excellent reducing agent. Yeah, it's something as a metal that will oxidize relatively easily. It'll become aluminum plus 3. And so since it becomes oxidized relatively easily, that means it's going to be pretty good at being a reducing agent. So D is true. It forms a hydroxide that is soluble in both strong base and acid. Yeah, so aluminum hydroxide can, as they say, dissolve in both strong bases and strong acids. No problem either way. So we would get B. This is one that I think is probably harder than you would see on more modern tests, just because the properties of aluminum, I don't know. I find it unlikely you would actually need to know them, but you know, if they ever did come up, here's an example of what they would be. 59, we've got a nuclear chemistry question. These are not that bad, even if you haven't studied nuclear chemistry. Just make sure your mass numbers and your atomic numbers are balanced or consistent. So, for example, if I have this missing symbol here, I've got 212 for my mass number on the left, and I've got 4 for the total mass number on the right. So that must mean what's left over must be 208 for the mass number, because 208 plus 4 gives us 212. So right away, that eliminates A, B, and C. And same thing with the atomic number. 82 would have to be the atomic number, because 82 plus 2 is 84. And if you look at your periodic table, we would see that 82 is lead. And so we get lead 82, 208. That would be choice E. Now we've got another equation. It's balanced. When 1 mole of NH3 reacts, which of the following is true? Well, some stoichiometry. So first, is 1 mole of N2 formed? Well, we're talking right now about 1 mole of NH3. So let's adjust the ratio accordingly. If we're dealing with 1 mole of NH3, then we are reacting that with 4.5 moles of Fe2O3 to produce 3 of this, a half of this, and 1.5 or 3 halves of that, right? We're halving everything. If we half the NH3, proportionally everything else will half. So this is false. This is false because we're going to form 1.5 moles. 3 moles of Fe3O4 are formed. That looks good because we do have 3. 2 moles of Fe2O3 must react. No. 4 moles of Fe2O3 must react. No, it's 4.5. So the one that is true is choice C.